So today we're going to talk about molecular and empirical formulas. There is a huge difference, and I think we've already decided that a molecular formula will be the original formula, and our empirical formula will be the simplest form that we can make that in, okay? So when I have this formula here, C6H6, I can simplify this by dividing both of these subscripts by what? A 6. So this formula will then become CH, okay, and that will be our empirical formula. So it is the simplest form of this formula. Now take a look at C5H10. What will we need to divide both of these numbers by to simplify those numbers? 5. So when we do that, 5 divided by 5, we will have 1C, and 10 divided by 5, we will have 2 H's. Okay? Simplified formula. Take a moment and think about this one. Think about what can we divide these three numbers by to simplify it. And just remember that all of these numbers end in an even number, so we always know we can divide by what? I see it, 2. Very good. So let's divide each of these by 2, and what do we get?
C3, H4,
O,
2.
2. Very good. So when I divide 12 by 2, I get 4.
how about 6?
6. Okay, very good. We make mistakes, it's okay. Don't do that again. Simple multiplication. And I told you I call your mama. Tell her that you can't multiply and divide. You got to do that. So find an app on your phone, like I told my students, if you just need to review those simple multiplication facts, and then you'll be able to do these types of things very easily. And that's where we're going now in chemistry. Lots of math. Okay? Now that we understand molecular formula and empirical formula, questions will ask you to write the empirical formula from the percent compositions. What am I talking about? Remember we did percent composition, percent of each element in the compound. So let's say I have this compound, a compound that has carbon, hydrogen, and oxygen in it. And I'm told that carbon is 48.38%, and yes, go ahead and write this down. Hydrogen is 8.12%, and oxygen is 43.5%. Well, there are 3 steps to follow that will help you find the empirical formula for this compound. The first step says to divide each percent by the atomic mass, okay? So this short lady is gonna come right back up here to this tall board and divide each one of these by the atomic mass. So, first step, 48.38 divided by, and this is for carbon. What is the atomic mass for carbon?
12.1.
Very good, 12.01. Okay, and I got that from the what? Where'd you get that from, Twin?
Periodic table.
Periodic table, very good. So 12.01. Sorry, guys. Now, for hydrogen, what do I have for its percent again? 8.12. And we divide that by what?
1.01.
Very good, 1.01. And we got that atomic mass again from the periodic table. Finally, we're going to look at oxygen, and its percent here is 43.5. And what is its weight?
16.
Okay, I just want to pull up my periodic table because sometimes y'all give me wrong stuff. Okay, so 16. Now, somebody has already put these numbers in the calculator, I'm sure, because you know I'm about to ask you some answers. What is 48.38 divided by 12.01?
4.02.
Thank you so much. Very good. And what is hydrogen's value? 8.12 divided by 1.01? Uh-oh, I'm about to call some mamas. So go ahead and put that in your calculator. Say it first. 8.12 divided by 1.01, and then do that in the calculator. 8.12 divided by 1.01. What's my answer?
8.04.
It is 8.04. And my final answer, somebody's done it for me. They don't want me to show how to.
59.5.
Thank you so much. So what? 2.72? Very good. Is that what we got?
Yeah. Put it in the calculator.
Do it one more time. Okay? So now, the next step says to do what? Step 2. Divide each of those by whichever is smallest. What do they mean? By these answers. Which one is the smallest answer? So 2.72. So I'm going to divide all of these numbers by what? 2.72. I'm going to do the easiest one first. What's 2.72 divided by 2.72? Okay. Hey, smart. What is 8.04 divided by 2.72? It is 2.96. And what is 4.03 divided by 2.72?
1.48.
1.5. Very good. 1.5. Now, I'm going to go ahead and tell you that if you've gotten to this step and you have these numbers, you're almost done. Now we have to find the lowest whole number. You know, y'all pull out those phones. I want to pause. Now we have to find the lowest whole number. What's the lowest whole number on the board? Whole number, not a decimal or anything. 1. It's the only whole number on the board. Okay? So now it says we found that lowest number. And first of all, I want to make this 2.96 a 3. These are going to be the subscripts for the formula. Have you ever seen a decimal or a half or anything like that for a subscript? No. Absolutely not. So we are going to multiply all of these by something to make this not be a decimal. And I'll just go ahead and tell you, when you see 1.5, multiply it by 2. Because 1.5 times 2 is what? You tell me.
3.
It is 3. So I have to multiply all of these by, I'm going to use a different color. Multiply all of these by 2 because I now have subscripts that I can use. Carbon will have a subscript of 3. Hydrogen will have a subscript of 6. And oxygen will have a subscript of 2. So now go ahead on your paper and write the formula for this compound. What did you write? C3H6O2. Did you just write this number on your paper for something? What did you write it for?
Empirical formula.
We wrote this as an empirical formula. Remember? I think the number before we multiplied everything by 2 or something. 6, I don't know, but this is the empirical formula for this compound. And we got this formula by looking at the mass, the percentages by mass. Okay? Now we're going to pause the video and I'm going to let you guys practice on some. Great job. So now we're going to practice a problem using the percentages in order to find the empirical formula. This sample has 40% carbon in it, 6.71% hydrogen, and 53.29% oxygen. What was the first step that we needed to do in order to solve this problem?
Divide each percent by atomic.
Absolutely. We're going to divide each percentage by the atomic mass of the element. Okay, so we're going to put this 40 divided by 12.01, yes? And where do we get 12.01 for carbon from? Periodic table of elements. Then we're going to take this value here, 6.71, and divide it by 1.01. Again, we got this atomic mass from the periodic table. And we're going to divide 53.29 by 16, which is the atomic mass for oxygen, also from the periodic table. So 40 divided by 12.01 is, it is 3.33. 6.71 divided by 1.01 equals 6.64. And finally down here, 53.29 divided by 16 is
3.33.
wow. 3.33. Step 2 says to do what?
Divide by the smallest number.
There you go, you back. Okay. Divide by the smallest number. Okay? Divide by the smallest number. What's the smallest number here? 3.33. Everybody can tell me this answer. What's 3.33 divided by 3.33? 1. And what is 6.64? I can already tell. That should be about what?
1.99.
1.99. And we know that we can do what? Make this a 2. We have what we need for our formula. This time we don't have to make anything, we don't have to multiply everything by another number, because everything kind of ended up being a whole number. So what will my formula be for this CHO compound? Carbon has what subscript? 1.
CH2O.
Look at you guys. What could be a possible, if this is an empirical formula, here we go with the higher level question. What could be a possible molecular formula for this compound? C6. So she's multiplying everything by what? 6. So C6, H12O6. What if I multiplied everything by 3? C3, H6O3. What if I multiplied everything by 5? C5, H10O5. I did this because I want you to realize that several molecular formulas can have the same what? Empirical formula. Several. Okay? Several. Very good. I think you guys got that.